Good afternoon, everyone. Thank you for joining us today for this Residential Energy Consumption Survey webinar. My name is Maggie Woodward, and I work as an industry economist in the Building Survey Statistics team in EIA's Office of Energy Statistics, the office that houses EIA's energy consumption surveys. Joining me today are Chip Berry, the survey manager for the RECS, and Greg Lawson, a modeling specialist from our end-use consumption team. This presentation will last about 40 minutes, and then we'll open up to questions. Today, we're going to discuss the consumption and expenditures data from the 2015 RECS. These data were released at the end of May, and they are the final set of data to come out from the 2015 RECS. The RECS has a broad audience today, and our participants are pretty diverse. After this webinar, we hope that you'll have learned more about the interesting trends in consumption and expenditures data from the RECS, and you'll have an appreciation for how the estimates for the 2015 RECS differ from prior vintages of the RECS. First, I'll show you some resources that are available on our website. Then, Chip will talk about some interesting highlights from the 2015 data. Next, Greg will give you an overview of the modeling process used for the 2015 RECS, highlighting ways that the methods have been improved from the 2015 RECS. After that, we'll have some discussion from Chip about preparations for the next RECS, and then finally we'll take time to answer some of your questions. Throughout the presentation, please feel free to use the chat feature of this WebEx session to submit questions you have for our presenters. So let's take a quick look at the products from the 2015 RECS. The housing characteristics data were published back in February 2017. After we got the consumption data from household energy suppliers, we made some adjustments to the weighting for the entire survey. So when we released the C&E data, we reissued the housing characteristics data. If you've been using the data, you may want to check to make sure you have the final estimates. Similarly, we updated the square footage tables, the microdata file, and the methodology documents. And of course, we published the C&E estimates themselves. So now, I'm going to take you live to our website to show you where you can find all of these items. You'll see a lot of our recent analyses up here in the carousel or lower down in the features section. To get to the data, you'll want to go to the Data tab up here. There are a few ways to navigate between the different years of data, but I like to use this drop-down menu. On the first tab, we have the housing characteristics data. This includes things like structural and geographic characteristics, space heating equipment information, household demographics, as well as our tabulations by characteristics by home size. We tabulate the data by many characteristics for each one of these topics, and to see the tables, you just click the heading like this to expand it. And as you'll see, each table is available in an HTML or PDF format, as well as an Excel download. And I want to note, the Excel files have the data as well as the corresponding error measures for each estimate. The C&E estimates are up here on a different tab. Here, you can find summary statistics, estimates by fuel, by end use, and by end uses by fuel. New this year, we've greatly expanded the number of end uses that we publish C&E estimates for. You can find these new estimates in the detailed tables right down here. If you're interested in working with our microdata, you're going to need to go to the microdata tab up here. The microdata file contains the individual responses from each household that participated in the RECS. You can use it to make your own estimates for topics that we don't include in the tables or to conduct further analysis. We make the microdata available in a CSV format as well as a FASTA file. We have a very handy PDF that gives a few examples of how to create estimates using both Excel and SAS, and you can find that right here. And I really recommend that as a resource if you're interested in getting started working with the microdata. Two other items that you're going to find really helpful are the code book and the survey forms. The code book is in Excel, and it gives you the name, the variable type, the description, and the response codes for all the variables that are available to you. If you want to see exactly how a question was presented to the respondents, take a look at the survey forms. You can access them by following this link, but I'm not going to dive into those today. All of these files were updated with the C&E release in May to include the new variables. Finally, let's take a look at the methodology tab. So here you're going to find all of the documentation that we've put out so far for the 2015 RECS. So that about covers it for the website, and now I'm going to hand things over to Chip to tell you about our findings from the 2015 RECS.
Okay, thank you very much, Maggie. As she said, my name is Chip Berry, and I'm the Program Manager for the Residential Energy Consumption Survey. And I want to personally thank you all for joining us today. If some of you may recall, we did a webinar last September, and we felt like that was really informative, and there was lots of engagement, especially in the Q&A. So hopefully we can, this can be just as successful as that one was. And these webinars are part of our initiatives as we release RECS data and look forward to the next, the 2020 RECS, and engaging on a deeper level with our data users. So thank you all for attending. As Maggie mentioned, I'm going to be looking at, so we're going to be looking at some highlights from the 2015 RECS data that were released at the end of May, the consumption and expenditures data. But before you do that, I want to provide a brief overview of some of the RECS sources and the methods. It's kind of how we make the sausage. So getting to the RECS results involves multiple surveys, statistical processes, uses of auxiliary sources of data like weather data, and some unique estimation models. Here on this slide, you see the cover of the paper version of the RECS household survey. And the household survey is the first of 3 major steps for each RECS. For the 2015 RECS, we used new paper and web questionnaires, as well as our traditional in-person surveys to capture information directly from households on things like structural characteristics, devices, and the systems that explain energy use in homes. We also collect the behavioral indicators that often distinguish one household from its neighbor. So a good example of that would be how a household interacts with their thermostat. The second step of a typical RECS then goes directly to each household's energy suppliers, for example, an electric utility. And we collect several months of billing data from those suppliers. And here you see an example of a typical set of electric bills for a 2015 household. And includes consumption in kilowatt hours in the middle column there, and in the third column is the monthly cost in dollars. And we've asked suppliers to provide us the data in the way that they're stored. So that means that the billing amounts we get are reliable, consistent, and pretty high quality data. And the cooperation from suppliers is extremely high, on the order of about 95% cooperation from the suppliers for which we ask for customer billing data. And you can imagine the quality of the data we get if we just ask our household respondents to tell us how many kilowatt hours they used in 2015. Okay. And then we annualize these bills, which is more or less, it's a little more complicated than just adding up, but it's more or less adding the bills together. And that allows us to get a calendar year total for each RECS household. There's some proration and imputation that goes on, which is used to adjust the bills to the exact calendar year and to fill in holes in the billing data. And the billing data form the basis for key statistics like household and per square foot consumption, and the distribution of energy costs across various geographies, housing types, or any other household characteristics. Okay, so we do the billing collection and we annualize, but we don't start there. There's a third step to each RECS, and we actually consider this the most valuable part of the RECS, and we refer to this as energy in-use estimation. So the bills can tell us how much electricity or natural gas or, say, heating oil is consumed in a year, but they can't tell us how much consumed for space heating or cooling or lighting or any other variety of in-uses that are in homes. So we've developed engineering-based models to produce in-use estimates. For the 2015 RECS, we released estimates for more than 25 household in-uses, and I've shown some of the electricity in-uses here. Certainly not all of them, but just some of those that we modeled. And my colleague, Greg Lawson, will cover our improved modeling phase in much more detail later in this webinar. But before we get to Greg, let's look at some actual results. So let's start with a simple time series of per household consumption, specifically showing average consumption across all the fuels that could be used in the home, electricity, natural gas, and petroleum sources. And it dates back, this graph dates back to 1993, or the 1993 RECS. The average consumption for occupied primary housing units in 2015 was 77 million BTU. I specifically mentioned occupied primary housing units because that's what RECS covers. We do not cover vacant consumption in vacant and seasonal homes or in common areas of apartment buildings. So you look at the 2015 average consumption of 77 million BTU, and you compare that to just 25 years earlier in 1993, where the average was above 100 million BTU. Migration to less energy-intensive regions in the West and South, and device efficiencies and structural changes help explain this trend. The RECS average consumption is also not weather normalized, so the warmer winter months in 2015 also helps explain the decline in 2015. Now let's look at consumption. Across and costs across region. In 2015, average site consumption was highest in the coldest places, not surprising. So households in both the Northeast and Midwest averaged 94 million BTU for consumption of natural gas, electricity, and petroleum fuels. In addition to similar weather, homes in these areas are also about the same size on average. But as you can see in the red dots here, households in the Midwest paid much less on energy bills than households in the Northeast. Almost 3/4 of Midwest homes use natural gas to heat, and natural gas prices in those states were lower than the U.S. average. In Illinois, for example, the average price for natural gas, residential natural gas, in 2015 was just about 80 cents per 100 cubic feet. In New York, the average price was about $1.20. So the RECS study allows for comparisons across various geographies, as well as subgroups within the residential sector. And like we've shown here, where we're comparing average consumption by housing unit vintage, or your home, the year the home was built. A home built since 2000 consumed about the same amount of energy on average as one built in the 60s, and that's shown in the darker blue bars here. For those of you who attended our webinar in September on housing characteristics, you might recall that we compared the presence of double pane windows across housing vintages. The RECS characteristics data show that 71% of homes built since 2000 had double or triple pane windows compared to just 55% of homes built in the 60s. So better windows, better insulation, reduced heating and cooling loads in homes, but these efficient features in newer homes are offset by the significant increase in the square footage of newer homes. And as indicated in the red lines here, homes built this century are 25% larger than those built in the 60s. Okay, let's look a little deeper at consumption by fuel. Since about 2005, natural gas and electricity have alternated as the most consumed fuel in the residential sector. Consumption for both fuels in the residential sector has been flat since then. In 2015, the RECS estimates show that electricity was the most consumed fuel by households nationwide. Electricity was the most consumed fuel in 2 of the 4 census regions. Fuel oil, which is partially represented here in green, commanded a noticeable share in the Northeast, and in that region, 1/4 of households still use fuel oil as a main heating source in their home. So the billing and bulk fuel delivery data can tell us average consumption and cost across the country, but they can't tell us anything about the devices that are consuming energy. And this is where that critical third phase of RECS is valuable. As I mentioned earlier, EIA has constructed engineering-based models along with various calibration techniques to derive energy in-use estimates for each fuel consumed in homes. And first, as you see here, let's look at some traditional RECS in-use comparisons. This graph shows heating, cooling, and related consumption by climate region. Space heating equipment and related devices like air handlers and dehumidifiers accounted for well over 40% of consumption in homes. Even in more temperate climates and in the hotter southern parts of the country, heating was still a noticeable share of consumption. As for air conditioning and related cooling devices, those in uses now accounted for 10% of consumption across the country. And it's as high as 24% in the areas where AC is used the most, and that's specifically that hot, humid region. The new in-use estimation methods are an improvement over the statistical regression modeling that we used in every RECS prior. So due to this switch in methodology, we're cautioning users to take note of this change if you're doing any kind of time series comparison with RECS in-use data specifically. And the chart shown here is part of a document we've produced on the RECS website, and it's called Comparing the 2015 RECS with Previous RECS and Other Studies. The most notable diversions from past RECS are with the electricity estimates. And as you can see here, relative to prior RECS space heating and water heating consumption are higher. So space heating is in red there at the bottom, water heating is in the yellow. And the refrigerator and that large other category that I talked about are lower in 2015 relative to prior RECS rounds. So I encourage you to go read that comparisons document. It's a pretty valuable tool that we have out there now. There are similar comparison charts for natural gas in that document as well. If you're all familiar with RECS, you'll notice I mentioned a few devices a couple slides earlier for which we have never produced in-use estimates before. For example, I mentioned dehumidifiers. In fact, as we highlighted in a Today in Energy article several weeks ago, the 2015 RECS data feature many more in-use estimates than we have ever produced before. The new engineering-based approach to modeling gave us confidence to release over 25 in-use estimates. Shown here is the expanded list of electricity in-use estimates. In the shades of red on the left-hand side are traditional in-use estimates that we've produced from RECS since the 1980s. On the right side, in shades of blue and gray, is the disaggregation of the old other category. There are now 26 in-use categories for electricity. And if you were to count up all of the categories on this graph, you'll get 22, so that begs the question, where are the other 4? So those other 4 come in when we further disaggregate TVs and related. We have separate estimates for most used TV and second most used TV. And then there's a similar disaggregation for refrigerators. We have estimates for most used refrigerator and second most used refrigerator. For the U.S. on average, there is no one in-use or device that dominates household electricity consumption. And now I'll turn it over to Greg.
Okay, thanks, Chip. Again, my name is Greg Lawson. I'm a member of the end-use modeling and estimation team for RECS. I'm going to give a brief overview of the methodology that we used for end-use estimation in the 2015 RECS and how it compares to the methodology used in prior RECS cycles. And as you will see, after some introductory material, I will focus on a simple but illustrative example. So, but first, to orient you, if we want to publish estimates for national and subnational end-use consumption, how will we do it? Ideally, we would rely solely on measurements, but sadly, though direct sub-metering of end-use consumption appears to be an ever more viable approach toward measuring what we're interested in, such a data set still does not exist over a representative national sample. So end-use consumption must be estimated from the information that we do have available. As Chip reminded us earlier, this includes the data from the RECS Housing Characteristics Survey, which tells us what fuels and end uses are present in a home and gives us some basic usage information. The data from the RECS Energy Supplier Survey, that allows us to compute annualized billing totals for the fuels present in a given home. Administrative data, most notably weather data, but also some census and geocoding data. And not to be discounted, but we have access to lots of very important information from the community at large in the form of published papers, studies, textbooks, and technical support documents for various regulations. End-use estimation, it reduces to a process of synthesizing the available information, which I just went over there in that previous slide. A useful way to think about this process is a two-step approach. So first, use information to form expectations about individual end-use consumption, and then correct or improve those expectations based on available measurements. So in our case, the Housing Characteristics Survey data and weather data can be used to set expectations on end-use consumption. The expectations are quantified by the use of models, which in turn are informed by wider community knowledge about individual end uses. Now, since the models are not measurements of a specific home, we would not expect their outputs to perfectly represent the actual values of end-use consumption in a given home. But we do expect them to be reasonable representations of the values. Now, on the other hand, the annualized billing data, they are essentially measurements of the total consumption from all end uses present in a given home for a particular fuel. This is valuable information, but it doesn't give much insight as to how the consumption is distributed across the end uses present. Thus, both expectations and measurements contain useful information about a home's end-use consumption, but neither is sufficient on its own. So we synthesize their information by a process we call calibration in order to obtain our final estimates. So to give you a sense of how models are used to set expectations for end-use energy consumption, consider an end-use model for coffee makers. This is about as simple an end-use model as you'll see, because the Housing Characteristics Survey does not collect any usage information, only whether a coffee maker is present. So in pseudocode, the model checks if a coffee maker is present, and if it is, then it assigns the annual consumption value to be something that we'll call P_coffee. Otherwise, the coffee maker, of course, consumes no energy. So in all RECS cycles prior to 2015, the expectations of end-use consumption were set by a process of statistical modeling, specifically nonlinear regression. Thus, P_coffee was left as an unknown parameter, along with a whole bunch of other unknown parameters and other models of end uses that also use electricity. All unknown parameters are solved for simultaneously using regression based on the annualized billing data. Once P_coffee has a numerical value, then the model is specified, and we have set our expectations for the energy consumption of coffee makers. This is a perfectly reasonable approach, but I'm going to caution you that P_coffee is part of a set of unknown parameters. All parameters in that set are sensitive to how all the other end-use models have been structured. And so, in other words, if we change something about maybe the space heating model, we might expect a change in our value for P_coffee. In 2015 RECS, we used engineering models. So, given that we only collect yes or no as to whether a coffee maker is present, the engineering version of this end-use model looks identical to the statistical one here, shown in pseudocode, with one crucial exception. Instead of solving for P_coffee using the measurements, we instead turn to the literature. We find a representative value of that unit energy consumption, or UEC, of a coffee maker. So now our expectations are set by wider knowledge of the community, and we think that this is an improvement for modeling smaller end uses like coffee makers. We also think the engineering approach is an improvement for larger, more complicated end uses like space heating and air conditioning. The overall consumption by space conditioning end uses clearly depends on many different things, including your building envelope and foundation properties, the building size and location, the weather, occupant behavior, and then the specific fuel and equipment that's present to provide space conditioning. Prior to the 2015 RECS, back in the world of statistical modeling, it was left to analysts to suppose functional forms for models with appropriate unknown parameters that could be solved for using the annualized billing data. Now this sounds reasonable, but these are potentially quite complex end uses to model in a mechanistic manner. So instead of trying to model the underlying mechanisms of heat transfer and the like, analysts instead experimented with whether space heating consumption seemed to depend best on the square root of heating degree days or perhaps linearly. And further, when using statistical models, there were different models for space heating for each fuel, which means that the regression solution values were potentially different for, say, natural gas heating than they were for propane heating. So in this 2015 RECS, analysts instead created models that followed engineering principles and tried to model the underlying mechanisms. In particular, a given building and its occupants imply a certain load to maintain the desired indoor air conditions. And then the efficiency of the fuel and equipment used to meet that load determine the actual energy consumption attributable to space conditioning. So the engineering model versions are fairly complex, performing so-called UA calculations to model heat conduction, calculating so-called normalized leakage to handle air infiltration into a building. Now, That's jargon, of course. Hopefully those terms mean something to many of you listening. Feel free to ask about them if you want in the Q&A. But in any case, we feel this mechanistic, unified approach to modeling is a definite improvement over the previous statistical method, and it definitely aligns better with wider community expectations on the energy consumption of space conditioning. So in all RECS cycles prior to 2015, this calibration process used was one of simple normalization. The residuals in that regression between the modeled sums of end uses and the annualized billing totals were simply prorated over the relative, based on the relative size of each modeled end use. So this approach effectively treats all expectations as if they were equally certain. And this is a completely reasonable approach, but we wanted to allow for varying levels of uncertainty across the suite of end use models. So therefore, in 2015 RECS, we changed this calibration method to one which has actually different names in different disciplines, but what we're going with is minimum variance estimation. So specifically, it does not treat each modeled end use as equally certain. However, to achieve this, we have to meaningfully specify the uncertainties of the modeled end uses, as well as the likely correlations between them. These are not easy tasks, but they can be tackled as described in our methodology document that Maggie showed you how to find earlier. Once these are specified, then the calibration process is basically a constrained minimization problem. So the constraints being necessary to ensure that the end uses sum to the annualized billing total and to ensure that no end uses end up with negative consumption. Okay, to give you a better feel for the whole end-use estimation process and to help contrast the previous and improved calibration methods, we're going to go through a simplified example. All right. Consider this hypothetical housing unit, which could have been in the RECS sample. We want to come up with the end-use consumption estimates for this home. Here is the available information. For the sake of simplicity, we consider only 3 end uses of electricity, which are air conditioning, refrigerator, and a coffee maker. And this is obviously unrealistic. We're not even considering lighting, which is in fact present in all RECS housing units, so keep that in mind. We're going to assume we can get weather records of both temperature and dew point temperature. And we assume that we received a full year of electricity bills from this home's energy supplier, and that once annualized, we find a total of exactly 2,000 kilowatt hours for the year. Okay, that's it. That's the list. How can we best use this information to make end-use estimates? I want to note that there are an infinite number of ways to apportion end-use consumption over these 3 end uses so that they still add to 2,000 kilowatt hours, and we just want to ask what is the best solution. So for the sake of this example, we will provide plausible model estimates for these end uses. Okay, these are our expectations as potentially set by either a statistical model or an engineering model. Here we think that AC used 1,000 kilowatt hours. The refrigerator used 500, and the coffee maker used 60 kilowatt hours, which of course sum to 1,560 kilowatt hours. Comparing the modeled sum to the annualized billing total of 2,000 kilowatt hours, we find that there is a difference of 440 kilowatt hours, and we will have to turn to calibration to synthesize the model expectations and the billing total measurement. Okay. So applying simple normalization, that calibration process that we used prior to the 2015 RECS, we're going to simply prorate that 440 kilowatt hours in accordance with the modeled values. So in practice, each modeled estimate gets multiplied by the fraction 2,000 over 1,560. This leads to the solution of AC using an estimated 1,282 kilowatt hours, the refrigerator using an estimated 641, and the coffee maker using an estimated 77 kilowatt hours. All right. Very well. These values do in fact add to 2,000 kilowatt hours, but they have treated the initial modeled values as equally valid. And so I ask, do we think that they are equally valid? Because I would say probably not. Refrigerators are relatively easy to model because they have well-documented parameters and consistent use throughout the year, whereas air conditioners are difficult to model, as I actually discussed several slides ago. And coffee makers cannot be modeled beyond their presence in a home, right? There's no usage data collected. So we have different confidence levels in the outputs from each of these models due to how easy it is to model the end uses themselves, and also just based on the fact that they use different amounts of inputs like usage. So let's try to quantify these. All right, while auditing the AC model for the 2015 RECS, we estimated that it has on average about plus or minus 50% uncertainty, which interpret as plus or minus 1 standard deviation. So in this case, for a modeled estimate of 1,000 kilowatt hours, we will assume plus or minus 500 kilowatt hours. So in contrast, the refrigerator model is more certain, and we estimate an uncertainty closer to plus or minus 20%, or in this case, plus or minus 100 kilowatt hours. For the coffee maker, there's such a large range of possible consumption values that perhaps plus or minus 100% or even more is appropriate. So if so, we're going to proceed with maybe plus or minus 60 kilowatt hours. Now, as far as correlations are concerned, we actually have no reason to believe that any of these three end uses have correlated consumption. And regardless, just for the sake of this simple example, we're going to assume that they do in fact have zero correlation with one another, though there are definitely end-use pairs where we would not want to ignore their correlations, like between clothes washers and clothes dryers. And I'll just quickly note, if you do some standard error propagation on these three end uses and compute the corresponding uncertainty of their sum, that's just the root sum square of the uncertainties that you see here, then you're going to find an overall uncertainty of plus or minus 513 kilowatt hours. Okay, this problem simplifies pretty nicely, by construction. There are no correlations to worry about, and because we are trying to gain an extra 440 kilowatt hours here, there's no threats of negative consumption to worry about. So the full optimization problem reduces to one that we can wrap our heads around. So basically that 440 kilowatt hour surplus, it gets distributed across the end uses according to their error variances, which is just the square of their uncertainties. And you can see the fractional weightings in the equations here. And if you evaluate them, then you find that the AC end use is now estimated to have used 1,417 kilowatt hours. The refrigerator is now estimated to have used 517, and the coffee maker is estimated to have used 66 kilowatt hours. So again, these add to 2,000 kilowatt hours, and they are they are different from the solution from simple normalization, which we've repeated here. Both solutions are from meaningful calibration methods that have now actually been used operationally. And so are the minimum variance estimates improved estimates? So we think that they are. If we bring them together, both sets of estimates into one table along with the uncertainty information, we can more easily compare them. So the first numerical column shows our initial expectations as set by our models. Second column shows the results from the previous calibration, that simple normalization method. And then, once we supplied the uncertainty and correlation information, we were able to implement the minimum variance approach and find the values in the last column. We can see that most of the 440 kilowatt surplus was given to the AC end use, which happens to be the end use with the largest absolute uncertainty. And this makes sense according to our own estimates of uncertainty, because it is much easier and, I would say, more plausible for a single error in the AC estimate to explain the overall 440 kilowatt hour difference than it is for anomalously large and coincidentally aligned errors in the refrigerator and coffee maker estimates. And then you can see that the refrigerator and coffee maker end uses receive relatively small corrections. Now, in the case of the refrigerator, this is because we have fairly good confidence in our model expectations. Accordingly, we are pleased to see a final estimate here closer to our model expectations than the previously calibrated value of 641 kilowatt hours. In the case of the coffee maker, despite the poor confidence in our model expectations, the end use itself is the smallest of the three. Minimum variance approach correctly determines that there just isn't enough information within the annualized billing total to meaningfully correct such a small end-use value, given the large uncertainty in the AC end use. So it's best to just leave the model expectation largely untouched. This illustrative example demonstrates how the results can change due to the new calibration methodology. Hopefully, you can now better appreciate why we believe the end-use estimation process has been improved, both the modeling and the calibration. Now I will pass control back to Chip, who will talk about the future of RECS.
Okay, great. Thank you, Greg. And if you go to the documentation on the RECS website underneath the 2015 data, if you look in the Appendix B section of the consumption expenditures documentation, you'll see a summary of each component of each published in-use model. And in addition to that, hasn't already been done, we're going to shortly be posting some references for each of those published in-use estimates. Okay, so even if you looked at the documentation already, check over the next day or so, and you'll see some additional information there. Okay, and again, this is a commitment to being more transparent about our processes than we have in the past. So, encourage you to look at that information. And these improved in-use estimation processes, just one of several notable innovations we implemented in the 2015 RECS. Our extensive use of web and mail surveys, in addition to supplement the in-person interviews, was another. And using web and mail is much more cost efficient, and it only takes about 80 days to collect characteristics data. This way of collecting data allows us to be much more flexible and responsive to our data user needs as we gear up to the next RECS. And I mentioned that we're looking at probably a 2020 reference year RECS. For one, we can increase the sample size for the next round, and that could include possibly covering 50 states. A larger sample also has the value of reducing sampling error for rarer items or smaller populations. So, say the characteristics of solar PV homes, for example. We could also begin to collect data more frequently and to reduce the time it takes us to publish data. More frequent data collection could come in the form of revisiting the same households over time, a longitudinal component to the program. We might also consider expanding coverage for special populations like low income or rural households, or we could utilize web and mail to dig deeper into specific topics. For example, we might expand our knowledge of household energy challenges or learn more about the behaviors that influence consumption. In addition to expanding the RECS scope beyond our traditional design, we're also exploring and actually now piloting related projects that might eventually inform and supplement the core program. One of these efforts is the current load disaggregation or submetering project. That's being conducted in collaboration with the Pacific Northwest National Lab. Load disaggregation technology is technology that can be attached directly to a home's electric panel or meter and either measures or estimates individual in-use consumption really in real time. And that has the potential to add a new sort of big data component to the RECS program. Over the next several months, we'll continue evaluating our options and to conduct outreach with data users, like many of you on the phone today, as we build objectives for the 2020 RECS. And I want to go ahead and put a plug in a couple weeks. Some of the RECS team and as well as the CVEX team will be out at the ACEEE summer study. We have a pretty big presence there with some presentations, a couple poster sessions. We'll be in some informal sessions. So I encourage you to introduce yourself. We can exchange business cards and talk about 2015 RECS results and how you're using the data, and also the future of the RECS program. Okay. All right, I'll turn it over back to Maggie now.
Wonderful. Thank you so much, Chip and Greg. We'd now like to open the floor to your questions. As a reminder, you can submit your questions to us using the chat feature of this WebEx session. One question that keeps popping up is, will the recording of this webinar be shared, or will we post the slides? The answer is yes. We do our best to do it in a timely manner. We have to transcribe the webinar, and that can take a little while to turn around, but we will get it up very soon, and we'll put a link right on our RECS homepage, so make it really easy for you to find. So our first question is, you talked a lot about coffee makers, but that isn't an end use that I see estimates for in the data tables. How did you choose which end uses to publish?
I guess I'll take this one. Great question. And we sort of kind of highlighted in our examples and some of the graphics, made sure to put coffee makers in there, hoping someone would ask this question. So thank you for asking the question, whoever did. There are actually, Greg, 85 individual in-use models.
For electricity.
For electricity, 85 individual in-use electricity models. Okay, there are also models for other, that produce estimates for other fuels, right? But not all models are created equal. So we only felt confidence in publishing the in-use estimates of highest quality. And I would say probably the primary consideration was given to the quality of the input data for those models. So I think as Greg alluded to, there are lots of models that the only input from RECS is just the presence of that device. For example, coffee makers. We only know if a respondent has a coffee maker that is used at least once per week. We don't know if they use it every single day, if they only use it once per week, if it's left on for 5 hours a day. So we had less confidence in models like that than we did of something like televisions, or first television, where we know how often it's used, the size, and the type. We have lots of really good information there. One of the end uses that you also don't see split out is computers, and the computers falls under sort of the same heading as coffee makers. We only know about the presence of laptops and tablets and computers. We didn't have complete information on usage questions. So thank you for that question.
Great. Next question, were there any houses where the difference between the modeled estimates of consumption and the actual consumption shown on the bills was so large that all of your calibration adjustments exceeded the uncertainty threshold?
Greg?
Yeah, okay. I can, in fact, there were, yes. So we have, and you'll see in the methodology document, but I did not talk about it in my portion of the presentation here. New to the RECS program this time around was the introduction of an unknown end use. This is an acknowledgement that there are definitely more end uses out there than the RECS survey has the ability to ask about, presumably mostly in electricity. However, all the fuels have an option to have an unknown component. So during the course of calibration, if we find an anomalously large, what we would say irreconcilable difference between the model expectations and the available measurement that we have on the total, then the calibration starts to think about whether there could be something unknown. Now, there are bona fide unknowns out there. We know from write-ins, like somebody reported a greenhouse heater, so like we're actually finding real unknown end uses, but sometimes it's also finding errors that are just in the data. You know, we do a great bit of editing to try to make sure everything looks great, but these are two separate surveys, housing characteristics and energy supply, and sometimes errors can make it through. And if you have a large error, it can, and you force it, you alias it onto one end use, like say space heating or cooling, you can corrupt that estimate in the process. So what we do is we have an unknown now which can preserve the accuracy of the end uses that we think we are modeling quite well. That kind of makes sense. So when those difference, in the question they said if all the uncertainty was not enough to account for that difference, that's when it would start to kick in and we would consider seriously that there might be an unknown end use.
In previous, the statistical models and the calibration in the previous RECS, that residual would have just been sprinkled throughout all the known end-use estimates. So.
Great. All right, so our next question is, there are some fields I see on the survey form but not in the code book, like heat other. Are there plans to eventually release those fields, variables?
Okay, another good question. So as I mentioned, we actually use 3 modes of collection in this round of the RECS. The traditional in-person the web and the mail. The traditional in-person interview, which is about an hour long, had a few additional questions that the web and mail forms did not. The heat other variable is one of those. And because the majority of responses came in via web and mail, we decided not to release any estimates of the in-person only variables. So that's why you may be looking through the in-person survey specification and see some variables for which we didn't release data. And we at this time do not have plans to release any of that information.
But if you want to check on something, feel free to reach out to us, and we can help you verify that it's not there, I guess.
And I did see another question about how do you give, and we've gotten this question before, about how do you give input into the questions for the next RECS. You know, there are some questions that are asked in person that we left out of the web mail. If you think some of those questions should be reinstated into the web mail, please let us know. We keep a running tally along the way of user input. There'll be a more formal process coming up within the next year or so, but we'll accept input anytime.
And our contact information for myself as well as for Chip and Greg is now on the screen, so you can reach out to any of us anytime. So our next question is, does EIA estimate seasonal or time differentiated household energy use? Obviously, most AC and heating is used in different seasons. Time differentiation could provide information useful for considering electricity peak reduction and or load management opportunities.
I'll start off and then Greg can add something.
Sure.
So the short answer is no. The 2015 RECS was the 14th iteration of the program that first started in 1978. And we have always just produced annualized estimates. You know, we do have monthly bills on site. I mean, this would be sort of a change in course or a supplement to the annualized estimates that we've always produced. And we've had some talk about some type of seasonal estimates or monthly or even taking advantage of smart meter data that's out there. Of course, you know, smart meters are not, living in Virginia, I don't have a smart meter, so you know, we're a nationally representative survey. But you know, as I mentioned, we're looking to expand the usefulness of the RECS program in the next years, and this could potentially be one area that we look at. Greg, you want to add anything about?
I think you answered that well. I will say that it has come up, especially as we updated the calibration method. There's an interest in it working with the monthly billing data in that realm as well, rather than an annualized total. So there are several reasons that we'd like to move that way, and hopefully we'll evolve that way for the next REC cycle.
Okay, great. Next question. Have you considered calculating what the end-use estimates would have been using your older nonlinear regression approach? I'd like to understand how much of the decline in electricity end use is due to the change in method versus real changes in consumption.
Greg, why don't you talk about some of the...
Well, we have attempted that exact recommendation. It's not precisely an apples-to-apples comparison as you'd hope, because of the changes in the surveys that have occurred from 2009 to 2015. But we have applied the nonlinear regression approach. We've done some attempt to do that. It's not perfect. We haven't published it or anything, but it showed that the results that we would have gotten would have looked more similar to 2009 than the ones that we did get. And we've also attempted the complement to that, which is applying some engineering models to the 2009 data. And though we didn't follow through with a full calibration in that sense, you could see that just the engineering model expectations were enough that they aligned more closely with what we found in 2015. Though, of course, there were different weather in 2009 and 2015. And we've done some other things like applying, like treating the 2015 survey as if the weather from 2009 had occurred at all the houses that we sampled. And we could see some differences in that, but in that instance, it remained more similar to what the 2015 results of 2015 weather is than by changing these methods. So we do have some evidence to believe that change in methodology is significant, hence the slide that Chip put up about cautioning with doing time series analysis. But we do believe that what we've done is an improvement. And
right. Yep.
Do you have anything to add to that?
Yeah, I put this graph up here again, and I mean, you know, aside from this pretty significant change in use estimation, you know, there are other changes across RECS cycles, including different sample sizes, sometimes different sample designs. You know, there are different interviewers.
Change in mode.
And in 2015, there's a change in mode. You know, so there are different things that come in that, you know, in general, with any survey, you want to caution data users about. But we felt it was really important this time to really highlight what's really a break in series with the in-use estimates. So if you're ever going to do any analysis of in-uses across, especially with electricity across RECS series, you really should alert your readers to the change in methodology.
Great. Here's another one. Do you compute the same operating hours for a central AC and a room AC for a sampled household?
That's a great question.
Yeah, okay, I'll try to answer. So as I tried to explain in one of my slides there, the way that the space conditioning models work is that, so for air conditioning, your building and your occupants, they imply a certain cooling load for the building. It's basically the demand for cooling that it would require to maintain the conditions that are desired. And so some of the inputs to that model do in fact include behavior. So, you know, how do you interact with your thermostat? What are your preferred set points during the day, during at night, and when no one's home? But it's only after you calculate that basic cooling load that you then consider what equipment is being used to service that load. And so whether you have a window wall unit, or whether you have a central AC, or you're running a heat pump as a central AC, the thing that differentiates those isn't so much the hours of operation, it is the efficiency of the equipment being used, so your SEER and whatnot. So that's the main differentiation. In fact, because we're dealing with annualized cooling degree days, you know, tallied and annualized electricity, and trying to get it out from that, we don't actually make the attempt to say what days, you know, or how many hours each day air conditioning was being used. So I hope that kind of answers your question, in that you can either say yes, it's assumed the same hours, or not, but really it's about how efficiently that equipment could be used to meet that BTU in cooling load.
Great, thank you, Greg, so much for that. We have another one. Why were the poverty flags eliminated from the 2015 RECS? Also, why were household income brackets so broad? And finally, why was the question regarding electricity service disconnection eliminated?
Actually, the electricity service disconnection should be there under the energy challenges section. I mean, it's related to, it's not, you know, it's not like there was a storm or something and you had a disconnection. It's related to not being able to pay your bills. But look in the energy challenges section for that. As for the poverty flag, that's a great question. You know, I should give a little bit more backstory about the use of web and mail. The original intent was we were going to run the traditional in-person survey alongside a piloted web and mail study, so they'd be conducted at the same time and essentially the same environment. And then we would you know, do the analysis and compare the results or whatever. But originally the official RECS estimates were going to come just from the in-person survey. We had run some pilot tests of web and mail, and it was going great. We were seeing really good representativity, despite lower response rates, seeing a really good representativity across a lot of characteristics. using the web and mail. And while we were learning about, we were getting these exciting results from the web and mail pilot studies, we were running the in-person and running just a little bit behind on getting responses and finding it tough to get responses as other federal agencies are finding right now with doing in-person surveys. So we actually decided to pull the interviewers out of the field and finish the study using web and mail. And so that's how we ended up with a mix. We designed the web and mail study so that it would fit nicely on about 20 pages of paper. And so in doing that, we did have to alter some questions or remove some questions. Earlier I talked about the does your apartment heat the heat other question. With the income question, that's one of the questions we had where we had to alter the response set. The in-person survey has about 20 or so response options, and there's a show card there when you're in person. You would take up way too much space on a piece of paper to have 20 income responses. So that's why the broader categories of income, and because of the broader category income categories, we couldn't calculate a poverty indicator. But again, I encourage anyone. This is great feedback, and this is actually something we identified prior. Is that maybe we need to go back to broader income or more defined income categories.
I also took the opportunity to pull up table HD 11.1, which is the new one for us, this RECS, and we also did a little write-up on household energy and security, which you can find linked to on our RECS homepage. And I'm going to go ahead and put our contact information back up again because we are running low on time. And so if we have not gotten to your question today, we will do our best to follow up with the folks in the chat and answer it for you by email. If you want to at any time, please also feel free to reach out to us. One last quick question that we'll take because it's something we get a lot. Do the BTU figures for electric heating reflect the 66% loss of combustion energy in generating the electric power? Or, I would assume the estimates for any electric end use.
That's right. No, so our data are only site consumption, so it's just the electricity being consumed at the home, and we don't produce what's generally known as like a primary electricity consumption number. So
awesome. Thank you so much, Chip and Greg. That is all the time we have for questions right now. Thank you, all of you, for listening and chiming in. It is so valuable to us to hear your questions and get this opportunity to talk to you. Please, please, always feel free to reach out to us with any other inquiries and comments. And like I said, we'll try to follow up with all of you whose questions we didn't get a chance to answer aloud today. Our information is up here on the screen. We will be making a recording of today's webinar available on our website, so check back soon if you missed anything or if you want to refer it to a colleague. We'll have a recording on YouTube as well as a transcript and the slides available soon. As you exit the webinar today, you should see a brief survey open in another window. Please keep an eye out for that. Let us know how we did and what topics you'd like to see for future webinars. And with that, we're going to conclude today's meeting. Again, here's our contact screen. Reach out. We really look forward to hearing from you and to hosting more webinars soon. Thanks.